between the t distribution and the z distribution in terms of the functionality. It's just a different command, all right? And it kind of works slightly differently, but not in a terrible way. So we need to find the mean and the standard error for the given data here. So the scenario, George is attempting to find how many text messages the average John Jay student sends in a month. Takes a simple random sample of 15 students and gets the following values. All right, so it's made up data. So I don't, in terms of conclusions, we're only going to get, the stock conclusion. It's not like we can actually draw a conclusion about John Jay students here. All right, so my first step would be to find the average. So equals average. Average. All right, I want the average of all this information here. So I'm going to highlight the first row, then comma, highlight the second row. So it's going to take the average of the values between B2 and H2 and also A3 to H3, right? Another way to do it, because averages only work with numerical values, is you could just highlight the entire cluster and go from there. But I prefer to do it this way. So hit enter. It asks if I want to do it again for the one below it. I don't. What I do want to do is find the standard error. So I'm going to do equals standard deviation for the sample. All right, so stdev.s. Then I'm going to do the exact same thing. All right, so I'm going to, take this row, comma, this row. But this is standard error, not standard deviation. So standard error is your S value. I realized that there was a typo there anyway, because I believe, those have sigmas. Those shouldn't have sigmas. It should be S sub x bar, right? Because we are not given the population standard deviation, nor can we figure it out, right? So I'm going to take this sample standard deviation and divide it by the square root of n, right? And that will give me my S sub x bar. Name, what's the problem here? Square root, why did I put n? Nobody knows. Square root of n, I actually have to put the n value there. So you could count them up. They tell us that there's 15 values, so you could go that way, or you could use a count function. So if I type count and open parentheses, this, comma, this, it'll count them all up for you. Now that's more beneficial when you have a large data set. When it's a small data set, it's easy enough to just actually count. All right, so I have my S sub x bar. I'm just going to make a note to myself to change this. Standard error S sub x bar for now. The confidence level, they're saying 95%. If they don't say, somebody asked me this last week, if they don't say what confidence level to use, you could choose your own, but the most typical confidence level is 95%. All right, so 95%, I have it set to put the percentage in there. Alpha is 1 minus your confidence level, so 1 minus this number, equals 1 minus this number. I have this set for decimal form, so it automatically makes it a 0.05. The topic that we're talking about here is number of text messages. The critical t-value, this is the thing that makes it different from what we were doing last time. The critical t-value, we're going to use the t inverse function, equals t dot inv. There's two options. The first one works the same way as the norm inv, or inverse norm, that we talked about last week. This one gives you the option of a two-tailed distribution, or a distribution that's shaded on the two tails. All right, so for this one, we don't have to worry about splitting the alpha value. In this case, we do. All right, so just out of consistency, I'm going to go with the first one. The alpha value is what I have here, divided by 2. And then the degrees of freedom, so count, again, you don't have to use the count function. It's a tool. It's a useful tool, and in a lot of cases, just not necessarily for this problem. All right. And so it spits back the critical t value. So again, t dot inv E9 is where I have my alpha value stored. I divide that by 2 and divide it by the count. Sorry, I missed the -1. Count -1. And then you'll see that it's going to return, well, it doesn't look like it in the cell here because I have too many values. So I'm going to just reduce the amount that I have there. So I'll just go 3 significant. All right, you see it's a negative number. All right, it's not the end of the world if you have a negative number because you can just drop the negative. But I like to throw an ABS around it. All right, so absolute value of the t inverse function, it returns a positive number. All right. So then for my low and high bounds, I guess I can expand this a little bit. Do it like that. The low bound, so it's always point estimate minus your critical value times the standard error. So point estimate x bar minus the critical value times the standard error. All right, so that's my low bound. My upper bound is the same stuff, just with a plus sign. Format, that's weird. So I now have my interval. What I want to do is make a statement, a conclusion statement. We are 95% confident that the number of text messages, the population mean number of text messages, is between the low number and the high number. All right, and you could do that with the concatenate function, or you could do it just by typing it out. Either way is fine. All right. The benefit of the concatenate function that we talked about last week is that you could copy paste that and use it again. So for example, I put in the assignment 2 the concatenate function, so I could just pull that and put it here. All right, so I have concatenate set up. Now I got to make sure it points to the right stuff. So my percentage value is, it's 95%, that's in B9. The statement of the topic is in G6. And A12 and B12 contain the actual interval values. All right, so we're 95% confident the population mean number of text messages is between 76 and 127. If you want to adjust the rounding, you can do that by, you see I have the round function here. A12, that command means round whatever I have in A12 to the nearest whole number. If I want to go 3 decimal places, I just put a comma 3. All right, so in this case, it looks like, yeah, okay, because the third value is 0, it just rounded it to 2. All right, so that's all we'd have to do for that one. The second example, really same stuff, just referring to a list of data rather than summary statistics. So it's again home prices. The X bar is going to be the average of whatever we have here, so equals average. All right. I don't want it to be duplicated. The S sub X bar, and again, like I said, when you do it correctly, efficiently, and using as many Excel commands as you can. You do that right the first time, then everything becomes copy pastable. All right, so this command here, you just pull it, And yeah, I might have to make some adjustments, but at least I have the bulk of it already accounted for. So this is A19 to A64. And I'm dividing it by the square root of the number of values that are in that list. All right. Now, again, formatting, it's not a big deal if the formatting gets screwed up, but it looks a little nicer if everything's uniform. So this came out with the wrong format. I wanted to have the same format as this one, so I would use the little paintbrush here, paint format, click on the one that I want it to look like, and then click on the one that I want to change. All right, so that's a fun fact of the day kind of deal. All right, 95%, critical t-value, same deal as up here. The alpha value, 95% confident. So that's going to be 0.05. But what I do is I just do 1 minus whatever's in this cell. All right? Because then if I change my 95 to a 99 just for the hell of it, I can see what the result would be all the way down the line. All right, so critical t-value, again, I can just pull what I have here, put it in here. All right, just make sure it's pointing to the right stuff. So my alpha value's in G21. A19 to A64 is where the data is. So now I have my critical t-value. I don't like the format, so I fix it. Oh, that's probably not a good one to use. It just made it a percent. So let me just take this one. All right, probably a few more decimal places. So just do that. For the bounds, again, do a little copy paste. See that it's pointing to the right stuff, and it is. All right, the E18 is my point estimate, D22 is my critical value, and E19 is my S sub X bar. Same deal here, E18, D22, and E19, so we're good to go. The format is kind of important if you want to do copy paste. So the reason why it actually changed to the right values is because the relationship between the locations of the point estimate, my standard error, and my critical value is the same here as it was up here. All right, so it's pointing to the right stuff. So now I can grab this, pop it in there. We are 95% confident that the population mean what? Must be pointing to the wrong thing. The topic I have in H18. Is between these two numbers. It's pointing to the right stuff. Again, if you want to play around with the rounding, you can. If you want to throw some dollar signs in there, because it's talking about money, you can do that too. But this is fine as is. All right. So the next tab is just the solved version of this, but we have it, so you don't need that anymore. Assignment 2. It's gonna. I left the template in here. You already saw that. So if you change these values that I have highlighted in yellow, it's going to automatically change your conclusion, so you don't have to worry about that. But what I want you to do is go to the Spinner website. All right. You're going to pick. So the example that I gave you previously was Westchester home prices. This is the mean. This is the standard deviation. What I want to do now is actually collect some real-time data. All right. So you go to the Spinner website and select 3 towns. All right. And for each town, you're going to go and look up 10 listings. All right. So the first town that came up is, for me, Mount Vernon. So I would go to Remax or Sotheby or like whatever real estate website, realtor.com, and find 10 listings. Very important, folks. If you go and look up a listing for listings for a town and you can't come up with 10 values, spin the wheel again. All right, because we need to have at least 10 listings. So I would go Now I'd go to Realtor.com, for example. I'd pop in Mount Vernon, and you see the listings. All right, so you need 10 of them. This one, so I would be able to use this. The first 10 that you see are the ones that you're recording. All right, you don't need to give me anything more than just the sale price. All right, so you pop that in, and then once you've completed that, you'll have your own data set. You'll go through, find the mean, the standard error. All right, the topic here is home prices again, so I could put that in. All right, or home price. Make it grammatically make a little bit more sense. But yeah, so your sample will be, it's going to be a stratified sample, 3 towns randomly selected, and then the first 10. So it's a combination of stratified and systematic.
It's 10 from each, right?
10 from each, yep. All right. So hopefully that makes sense. If you have any questions, let me know, and I will assist.